Moving on to question number 6, part A. By sketching a suitable pair of graphs, show that the equation this cot x is equals to 2 minus cos x has one root in the interval x is from 0 to half pi and 0 is not. So now we'll say that y is equals to cot x. This is one equation, and then the other equation is going to be, so this is our first equation, that y is equals to cot x, and then our other equation is going to be y is equals to 2 minus cos x. Now the simplest way to solve this is to just make a table of x and y values, and simply, now y is equals to cot x basically means that y is equals to 1 upon tan. I'm simply just going to assign some values to x. So x has a range of 0 to half pi, but 0 is not included. Let's say if I start from 1 upon 4 pi, then 1 upon 3 pi, and then 1 upon 2. So the corresponding y values are 1, 0.6, and then infinity. Basically, infinity means that over here there's going to be an azimuth. Now I'm going to do the same with this equation. I'll assign the same values: 1 upon 4 pi, 1 upon 3 pi, and 1 upon 2 pi. And the corresponding y values are 1.3, 1.5, and 2. And now I'm going to make the sketch. This is our y-axis, this is our x-axis. Firstly, I'm going to sketch this y is equals to cot x. So I'm just right, so I'll just assume I'm not gonna mark these axes because they said sketch, so I'm just assume, right? So first point is 1 upon 4 pi and 1, so let's say it's somewhere over here, right? And then they said 1 upon 3 pi with 0.6, so let's say it is somewhere over here maybe, right? And then it's at half pi, there's basically an asymptote. So the graph is somewhat going to be right? So this is the graph for y is equals to cot x. And now for this one, 2 minus cos x. So at 1 upon 4 pi, it's 1.3, right? So it's somewhere over here. And then at 1 upon 3 pi, it's 1.5. So it's somewhere over here. And then at half pi, it's 2, somewhere over here. So the graph is somewhat going to be like this. And this is y is equals to 2 minus cos x. And we can clearly see that there is just one intersection point in the interval of x is from 0 to half pi. So this is our final sketch. And now, show by calculation that this root lies between 0.6 and 0.8. So this was our equation, that cot x is equals to 2 minus cos x. So instead of cot x, I'm going to write 1 upon tan x is equals to 2 minus cos x, and then I'll say that 1 upon 2 minus cos x is equals to tan x. So basically over here I have to separate this variable x. Yes, I have to separate one variable x. Basically I can separate x from tan x, or I can separate x from cos x. To solve these kinds of questions, we have to show that the root lies between certain range. You firstly have to separate that variable. You can, in this case, you can separate x from tan x or cos x. So I'll separate it from tan x. So it's basically going to be tan inverse of 1 upon 2 minus cos x is equals to x. And I'm gonna take this x to one side, and then I'm gonna take this whole term to this side, and then this becomes x minus tan inverse of 1 upon 2 minus cos x is equals to 0. And then I'll say that let f of x equal x minus tan inverse of 1 upon 2 minus cos, and then I'll say that f of 0.6, I'll put these two values 0.6 and 0.8, and if there is a sign change, then that means that x lies between, the root lies between 0.6 and 0.8. So 0.6 minus tan inverse of 1 upon 2 minus cos of 0.6. While calculating, make sure that your calculator is in radian mode. So the answer is minus 0.105, and then f of 0.8. It's 0.8 minus tan inverse of 1 upon 2 minus cos 0.8, and this is 0.146. And we can see over here that there's a sign change. You can write that there is a sign change, hence root lies between 0.6 and 0.8. This is it for part B. Part C, use the iterative formula this to determine the root correct to 2 decimal places and give the result of each iteration to 4 decimal places. So firstly, let's say that x0 or x0 is equals to 0.7. The 0.7 lies exactly midway between 0.6 and 0.8. That's why I chose 0.7. And now x1 will be, I'll just put this value in this expression. So tan inverse of 1 upon 2 minus cos 0.7, and it's 0.6806, correct to 4 decimal places. Then find x2, I'll put tan inverse of 1 upon 2 minus cos of 0.680 index, that's 0.6855, correct to 4 decimal. Now x3, tan inverse of 1 upon 2 minus cos of 0.6855, and it's 0.6843. x4, tan inverse of 1 upon 2 minus cos of 0.6843, 0.6846. And now the root x is equals to 0.68, and 0.68 is our final answer. Now in the question they asked us to find the root correct to 2 decimal places. So how do we know till which x value we have to stop? So basically round these values to 2 decimal places, and when you get the same values, that is the answer. Like if I round this value to 2 decimal places, it's gonna be 0.68. If I round this value to 2 decimal places, it's gonna be 0.69. If I round this value, it's gonna be 0.68. And if I round this value, it's gonna be 0.68 again. When you have two consecutive same values rounded to 2 decimal places, in this case, sometimes they ask us to give the answer till 3 decimal place. So then you have to round it to 3 decimal place, and then when you get the same consecutive answers, that's your answer. So in this case, it's 0.68. So this is it for question number 6. Moving on to question number 7, part A. By expressing 3 theta as 2 theta plus theta, prove the identity this. Thus cos 3 theta is equivalent to 4 cos cube theta minus 3 cos theta. So cos 3 theta can be written as cos 2 theta plus theta, right? So now we are going to expand this. Cos 2 theta cos theta minus sin 2 theta sin theta. Now we have 3 different ways to solve this identity cos 2 theta. We have 3 different ways, but if in the answer you can see that we need answer in terms of cos, so we are going to use this identity that cos 2 theta is equivalent to 2 cos square theta minus 1. So 2 cos square theta minus 1 multiplied by cos theta minus sin 2 theta is just one way of expanding, 2 sin theta cos theta multiplied by sin theta. So now this becomes 2 cos cubed theta minus cos theta minus 2 sin square theta cos theta. And now, since in this equation you can see we have sine, but we want every term to be in cos, so we can use this identity that cos square theta plus sine square theta is equals to 1. So sine square theta is equals to 1 minus cos square theta. So 2 cos cube theta minus cos theta minus 2 into 1 minus cos square theta cos theta. 2 cos cube theta minus cos theta minus 2 cos theta, and then minus plus, and then 2 cos theta being multiplied by cos square theta. So it becomes 2 cos cube theta. this is basically the same as this thing, that 2 cos theta multiplied by 1 minus cos. This thing is the same as this, right? So now 2 cos square theta plus 2 cos square theta is 4 cos cube theta, and then minus cos theta minus 2 cos theta is minus 3 cos theta. So hence shown that this identity is proven. So now we can say that this is equivalent to 4 cos cube theta minus 3 cos theta. We can say that left hand side is equals to right hand side. So hence proven, or you can write. Moving on to part B. Hence solve the equation cos 3 theta plus cos theta cos 2 theta is equals to cos square theta, for theta is from 0 to 180 degrees. So instead of cos 3 theta, we're going to use this identity, 4 cos cube theta minus 3 cos theta. 4 cos cube theta minus 3 cos theta plus cos theta cos 2 theta is equals to cos square theta. Again, to solve this part, cos 2 theta, I'm going to use the identity that cos 2 theta is equals to 2 cos square theta minus 1. I'm using this identity because all the terms are in cos. So we have 4 cos cube theta minus 3 cos theta plus cos theta multiplied by 2 cos square theta minus 1. And I'll bring this cos square theta to this side as well, so it becomes minus cos square theta is equals to 0. So now 4 cos cube theta minus cos square theta minus 3 cos theta plus 2 cos cube theta minus cos theta is equals to 0. So 4 cos cube theta and 2 cos cube theta becomes 6 cos cube theta, then minus cos square theta, and then minus 3 cos theta, and minus cos theta becomes minus 4 cos theta is equals to 0. What we can do is that we can take cos theta common. So this is cos theta taken out. We have 6 cos square theta minus cos theta minus 4 is equals to 0. So over here, product of two terms is equals to 0 means either term is equal to 0. So cos theta is equals to 0 and 6 cos square theta minus cos theta minus 4 is equals to 0. Now cos theta is 0. So see the range of theta is just from 0 and 180. If you see the graph of cos, it's like this. This is 90, this is 180, this is 270, and this part is 360 degrees. So cos theta is 0 at 90 degrees and at 270 degrees. But the range of theta is just from 0 to 180, so that means that theta is just 90 degrees. And now moving on to this equation. So if we try using the midterm breaking formula, so we need minus 24 and the difference should be 1. So that's going to be complicated. I'm going to use a quadratic formula over here. I'll say that cos theta is equals to minus b plus minus square root of b square minus 4 under root of b square minus 4ac divided by 2a. So cos theta is equals to minus into minus 1 plus minus. Remember that this is a, this minus 1 is b, and this minus 4 is c. Plus minus under root of minus 1 squared minus 4 into 6 into minus 4 divided by 2 into. So after just putting it in the calculator directly, I get one value of cos theta as 0.9041, correct to 4 decimal places, and the other value of cos theta is minus 0.7374, correct to 4 decimal places. And now when I saw that, so firstly I'm going to look at this, that cos theta is equals to 0.9041. So when I do that, I want to find alpha first. Alpha is the basic angle, so alpha is going to be cos inverse of 0.9041. Alpha is 25.3 degrees, and over here alpha is cos inverse of minus 0.7374. Moving on to question number 8, it's given that this is equals to this, where a and lambda are real constants, and we have to show that 3a squared plus 4a minus 4 is equal to 0. So 2 plus 3ai upon a plus 2i is equals to lambda multiplied by 2 minus I. So we can see that there are constants over here. There's a, there's lambda. I is always there in complex numbers. So firstly what we're going to do is that we're going to cross multiply to make it like simple to make it simpler. So 2 plus 3ai is equals to lambda into 2 minus I into a plus 2i. And now we're going to expand it. 2 plus 3ai is equals to lambda. 2 into a is 2a plus 2 into 2i is 4i, and then minus plus minus ia, and then minus plus becomes minus 2i squared. Now we know that I square is equals to minus 1, so we'll substitute this. So 2 plus 3ai is equals to lambda into 2a plus 4i minus I minus ia minus 2 into minus. So it's 2 plus 3ai is equals to lambda into 2a plus 4i minus ia plus 2. And now we'll expand it, like we'll multiply each of these terms with lambda. 2 plus 3ai is equals to 2a lambda plus 4i lambda minus ia lambda plus 2 lambda. And now when you've reached this point, how are you going to know how to solve it further? So it's basically like in complex number we studied this thing in solving complex equations, that real part is equal to the real part and imaginary part is equal to the imaginary part. So all the parts that have I with it is the imaginary part. So this real part 2 is basically equals to 2a lambda and 2 lambda. So 2 is equals to 2a lambda plus 2 lambda. We can take lambda common again, 2a plus 2, and then we can say 2 upon 2a plus 2 is equals to lambda. Again we can simplify it further by taking 2 common, so it's a plus 1 is equals to lambda. So 1 upon a plus 1 is equals to lambda, and imaginary part is equal to imaginary part. So basically 3ai is equals to 4i lambda minus ia lambda. I can simply just cancel these i's because they're on both the sides, and with every term again I'll take this lambda common, so 4 minus, and we just found out lambda in terms of a, and we just found out what is lambda in terms of a. It's 1 upon a plus 1. So I'll substitute it over here, that 3a is equals to 1 upon a plus 1 into 4 minus a. So I'll take it to this side and I'll multiply it with 3a into a plus 1 is equals to 4 minus a. So it's 3a squared plus 3a is equals to 4 minus a. Now I'll take them to one side, and it will be 3a squared plus 3a minus 4 plus a is equals to 0. So it will be 3a squared plus 4a minus 4 is equals to 0, and hence we have shown this is the same equation, right? So moving on to part B. Hence find the possible values of a and the corresponding values of lambda. So this is the equation that we have, 3a squared plus 4a minus 4 is equals to 0. It's a quadratic equation. You will find two values of a and then you will find the corresponding values of lambda. This is easy. right? So it's 3a squared plus 4a minus 4 is equals to 0. We can do midterm breaking or we can use quadratic formula. Let's quickly see if we can do midterm breaking. So 3 4s is 12, and then the difference should be 2. The difference should be 4, so it's 6 and 2, right? So 3a squared plus 6a minus 2a minus 4 is equals to 0. So these are the 6a and 2a. And now we can take 3a common over here, and it will be a plus 2. So over here also it should be a plus 2. So the outside remaining is minus 2 is equals to 0. So one is 3a minus 2 is equals to 0, and the other one is a plus 2 is equals to 0. So 3a is equals to 2 and a is equals to 2 upon 3, and over here the other value of a is minus 2. Now over here we saw that 1 upon a plus 1 is equals to lambda. So 1 upon a plus 1 is equals to lambda. Now when a is equals to 2 upon 3, lambda is 1 upon 2 upon 3 plus 1. So lambda is 3 upon 5. And now when a is minus 2, lambda is minus. The corresponding values are when a is 2 upon 3, lambda is equals to 3 upon 5, and when a is equals to minus 2, lambda is equals to minus 1. These are the final answers of question number 8 part. So moving on to question number 9. The diagram shows the curve y is equals to sine x cos 2x. Find x is from 0 to pi and a maximum point m where x is equals to a. Now the shaded region between the curve and the x-axis is denoted by r, and we have to find the value of a correct to 2 decimal places. So whenever we hear the word maximum point or minimum point, this is the first thing that comes to our mind, that dy by dx at that point is going to be equal to 0. So now I'm going to find dy by dx at x is at m, the expression for dy by dx, and then I'm going to equate it to 0, and then I'm going to find the value of a basically, not x, like x is equals to a, right? So y is equals to sine x cos 2x. I'm going to use product rule over here. So u is equals to sine x and v is equals to cos 2x. So u dash is equals to cos x and v dash is equals to negative sine 2x multiplied by 2. So it's negative 2 sine 2x. Now dy by dx so dy by dx is equals to uv dash plus vu dash. So it's basically sine x multiplied by minus 2 sine 2x plus cos 2x multiplied by cos x. So this is minus 2 sine x sine 2x plus cos x cos 2x. Now this is our expression for dy by dx. At m, dy by dx is equals to 0 and x is equals to a. So now I'll replace x with a. It will be minus 2 sine a sine 2a plus cos a cos 2a is equals to 0. Since there's nothing common over here, so I'm just gonna send this negative term to the other side, and it will be cos a cos 2a is equals to 2 sine a sine 2a. And now I can expand the sine to a, so cos a cos 2a is equals to 2 sine a multiplied by 2 sine a cos a, and this will be cos a cos 2a is equals to 2 2s are 4 sine squared a cos a. Now we can see that there is this sine squared a in our equation, which can be converted to cos using this identity, that sine squared a plus cos squared a is equals to 1. So sine square A is equals to 1 minus cos square A. Right, and now to solve this double angle identity cos 2a, we basically have we have three ways to solve this identity of cos 2x, but we are going to use this one, that cos 2a is equals to 2 cos square a minus 1. We are using this one because every term in this equation can be converted to cos. So cos a multiplied by 2 cos square a minus 1 is equals to 4 into 1 minus cos square a into cos a. So this is 2 cos cubed a minus cos a is equals to, so this thing is the same as 4 cos a being multiplied by 1 minus cos square a. So 2 cos cubed a minus cos a is equals to 4 cos a minus 4 cos cubed a. And I'll take these terms to this side. So this becomes 2 cos cubed a minus cos a minus 4 cos a plus 4 cos cubed a is equals to 0. So then it becomes 6 cos cubed a minus 5 cos a is equals to 0. Now from here I can take cos a common. So cos a taken common, now I have 6 cos square a minus 5 is equals to 0. So product of two terms is equals to 0, that means either term is equal to 0. So cos a is equals to 0 and 6 cos square a minus 5 is equals to 0. Now I'll continue on the blank page, on the additional page. So it's question number 9 part A. We have cos a is equals to 0 and we have 6 cos square a minus 5 equals 0. So cos a is equals to 0 when the values of a are half pi and 3 upon 2 pi. But according to question number 9, we can see over here that x can only be from 0 to pi, right? X can only be from 0 to pi. X can only be from 0 to pi. So hence a can take only half pi over here from this part. Now to solve this part, 6 cos square a is equals to 5. Cos square a is equals to 5 upon 6. Cos a is equals to plus minus under root of 5 upon 6. So according to this, cos can be in all the quadrants 1, 2, 3, 4. But according to our range of x over here 0 to pi, that means the quadrants allowed are only first and second, right? So first let's find alpha. Alpha is equals to cos inverse of under root of 5. Check it. So it comes out to be 0.4205, right? So this is our alpha, and this is also the value for the first quadrant. Now to find theta in the second quadrant, how do we do that? We subtract alpha from pi. So pi minus 0.4205, and that is 2.7211. Now x has values half pi, 4205. It's 4205. 0.42 and 2.72, right? But according to question number 9, a can only have one answer, right? A can only have one answer. So the answers were x is equals to half pi, 0.42 and 2.72. Let's check what is half pi. Half pi is equals to 1.57. So we can see that a is closest to 0, right? Like a is over here, and the smallest value of x is 0.42, because this is our one maximum point, then this is our minimum point, and this is again a maximum point. So this is 0.42 and this is 1.57, and this point is 2.72. So a has value 0.42 correct to 2 decimal places. A has value 0.42 correct to 2 decimal places. And this is our answer to question number 9 part A. Moving on to part B. Find the exact area of the region R, giving your answer in simplified form. So now we have to find the area of R. So this is our region, right? So basically what are we going to do? We are going to integrate this expression of y within the limits this and this. And we have to find these limits by substituting y is equals to 0. So first let's find that. Y is equals to sine x cos 2x, right? Sine x cos 2x. Now when I equate y to 0, this is sine x cos 2x. So product of two terms equals to 0. So that means that sine x is equals to 0 and cos 2x is equals to 0. Sine x is equals to 0 when x is equals to 0, pi and 2 pi, right? But according to our range, only 0 and pi are allowed. Now over here, cos 2x is equals to 0. Don't just do it like this, that 2 cos 2x is equals to 0. Now to solve this, don't just go that 2x is equals to cos inverse of 0 and then you say that 2x is equals to half pi and then you solve it. No, this is the wrong way, because when we do it this way, one solution will be missing. Why? Because we have cos 2x over here. Generally when we get something with x, you know the how we change the range and all of that. So we won't do it over here, but we can use an identity instead. Cos 2x we also know the cos 2x can be written as 2 cos square x minus 1 is equals to 0. So 2 cos square x is equals to 1, cos square x is equals to half, and cos x is equals to plus minus under root of half. Again, according to the range of x, it's just one first quadrant and second quadrant. So alpha would be cos inverse of under root of half, which would be 1 upon 4 pi, and then the second quadrant would be pi minus 1 upon 4 pi, which would be equal to 3 upon 4 pi. So basically the x values are 0, 1 upon 4 pi, 3 upon 4 pi, and pi. And if we look in the diagram, this is 0, this is 1 upon 4 pi, this is 3 upon 4 pi, and this is pi. So our range, the values, so basically our limits are 1 upon 4 pi and 3 upon 4 pi, right? So now we're going to integrate sine x cos 2x with respect to x within the limit 3 upon 4 pi and 1 upon 4 pi to find the area of R. Right, so now we can do it by integration by parts, or we can do it by substitution also, but in that case we will have to make a substitution ourselves. So I'm just going to go with integration by part, right? So since both of these terms are like, and also make sure that whenever you're integrating something related to trigonometry, the trigonometry like the sine, cos, or tan, they should always be linear. Like they shouldn't have a power 2 or 3, like they shouldn't be cos square x or sine square x. They should always be linear. In this case they are linear. So since both are according to late rule, right, trigonometry, both are trigonometry, so u is equals to sine x and v dash is equals to cos 2x. So u dash will be cos x, and we are going to integrate this. When you integrate cos 2x, it is sine 2x upon 2. Now the formula is this: when you integrate uv dash with respect to x, it is uv minus integration of vu dash with respect to x. So uv is sine x and sine 2x upon 2. This is solved within the limits 3 upon 4 pi and 1 upon 4 pi minus integration of sine 2x upon 2 multiplied by cos x. So that's basically the integration of sine x cos 2x with respect to x within the limits of 3 upon 4 pi and 1 upon 4 pi. Now we can clearly see that it is integration by parts, but that's often difficult. So what I'm gonna do over here, I'm gonna do this by substitution. So firstly, we're gonna use this identity that cos 2x is equals to 2 cos square x minus 1. So I use this, and then sine x multiplied by 2 cos square x minus 1 with respect to x, 3 upon 4 pi and 1 upon 4 pi. And now I'm also going to separate it, like integration of 2 cos square x sine x, right, with respect to x within the limits 3 upon 4 pi and 1 upon 4 pi, minus integration of sine x with respect to x, 3 upon 4 pi and 1 upon 4 pi. And now over here I'm going to take the substitution that u is equals to cos. You basically take a substitution that can be converted into all of the terms that you have. So when we take the substitution u is equals to cos x, we will firstly differentiate it. So du upon dx is equals to minus sine x, and then minus du upon sine x is equals to dx, right? And we also see the limits. So u is equals to cos 3 upon 4 pi, which is 1 upon under root 2, and then u is equals to cos 1 upon 4 pi, which is minus 1 upon under root 2. So further, so now it's basically that if I write this term first, it is that integration of 2u squared sine x multiplied by minus du upon sine x with respect to 3 upon 4 pi and 1 upon 4 pi. And that's how this sign and this sign gets cancelled. And now we can take the minus term out, minus sign outside, and it will be integration of 2u squared with respect to u within the limits, the limits are 1 upon under root 2 and minus 1 upon under root 2. So it's 1 upon under root 2 and minus 1 upon under root 2. So it is 2u cubed upon 3, the minus sign here, with 1 upon under root 2 and minus 1 upon under root 2. Solving it minus, so I put the values 1 upon under root 2 cubed upon 3 minus 2 into minus 1 upon under root 2 cubed upon 3, and then after solving everything, the answer is minus under root 2 upon 3. The answer is minus 2 upon under root 3. This is by solving this one. And now when we solve this, we can easily do this. We can simply do. So I'm going to go to the blank page again, the additional page, sorry. And this is question number 9, part B. Integration of sine x with respect to x within the limits 3 upon 4 pi and 1 upon 4 pi. And we can simply do this. It's going to be in the minus sign over. So minus sign over here. And when we integrate sine x, we get negative cos x. That's from 3 upon 4 pi to 1 upon 4 pi. And the minus minus will become plus. So it's just cos x within 3 upon 4 pi and 1 upon 4 pi. So this is cos 3 upon 4 pi minus cos 1 upon 4, and the answer is under root 2. Easily going to be minus sign outside, and integration of sine x is negative cos x within the limits 3 upon 4 pi and 1 upon 4 pi. And do not solve this, because basically when minus sign is in the modulus, so everything becomes positive, right? So it basically becomes minus cos x of 3 upon 4 pi and 1 upon 4 pi. These are the same things, because whenever minus sign is in modulus makes everything positive, right? So minus sign outside, cos 3 upon 4 pi minus cos 1 upon 4 pi, and it is minus under root 2, right? So now it is under root, बस modulus में sign multiple नहीं करो. So we have this negative sign outside. Integration of sin x is negative cos x with respect to 3 upon 4 pi and 1 upon 4 pi. Do not solve this minus and make them positive. So minus cos 3 upon 4 pi minus cos 1 upon 4 pi. Minus cos 3 upon 4 pi is under root 2 upon 2 minus cos 1 upon 4 pi itself is minus under root 2 upon 2. So this is minus modulus of under root 2 upon 2 plus under root 2 upon 2. So this becomes under root 2. Because it's below, right? That's why. So it is minus under root 2. And now final answer, we are going to add them together. So it's minus 2 upon under root 3. So it is minus 2 upon under root 3 minus under root 2. And the answer is minus 2 under root 2 upon 3. But as you can see over here that r is below the x-axis, the answer we have gotten has, of course, is negative, but area cannot be negative, so that's why we are going to consider this positive. So it's 2 under root 2 upon 3. We got this minus sign because area r is below the x-axis, but area cannot be negative, so that's why the final answer has to be positive, and it's 2 so it's 2 under root 2 upon 3. And this is the final answer for question number 9, part B. Moving on to question number 10. The equations of the lines L and M are given by this, that L has this equation and M has this equation, where C is a positive constant. It's given that the angle between L and M is 60 degrees. We have to find the value of C. So when they give us the statement that the angle between L and M is 60 degrees, this states that we have to use scalar product, okay? And in scalar product, the formula is like AB vector multiplied by BC vector is equals to the magnitude of AB vector multiplied by the magnitude of BC vector multiplied by cos theta. Suppose this is your line L and this is your line M. So this angle is 60 degrees. Now using this information, we have to find the value of C. Now these AB vectors and BC vectors are basically the direction vectors. Remember, these are not this vector, these are not this vector, this is this vector. In line equation, when we make vector equation, this part is known as the direction vector, and this is the vector that we have to include in our scalar product formula. So I'll say that 1, 1, 2 dot minus 2 4c is equals to, when we find the magnitude, we basically square each number and add them. So 1 square plus 1 square plus 2 square multiplied by minus 2 square plus 4 square plus c square into cos 60. Now 1 into minus 2 is minus 2 plus 1 4s are 4 plus 2c is equals to 1 plus 1 is 2, 2 plus 4 6, it's under root 6 multiplied by minus 2 square is 4 and 4 square 16. So 16 plus 4 is 20 plus c squared into cos 60 is half. Now if you look at this part, so there's this thing that whenever in an under root two numbers are being multiplied like this, so you can separate them together, like under root a multiplied by under root b. And likewise, if two numbers are separate in under root, like under root a into under root b, you can combine them together by writing them under just one under, only one square root. But remember, you can only combine or separate these square roots only when they're being multiplied. If they're being added or subtracted, we cannot separate these square roots. So minus 2 plus 4 is 2 plus 2c is equals to under root 6 multiplied by 20 plus c squared, right, into half. Now I'll send this half to the other side, right? I'll send this half to the other side and it will be multiplied 2 plus 2c is equals to, and I'll just write it like this for now, 20 plus c squared, and then it will become 4, it'll become 4 plus 4c is equals to under root of 6 into 20 plus c squared. Now what should I do to get rid of the square root? Right, we have to square both sides. So this squared and this squared. So this square and this square root will be cancelled, and this is of the form a plus b whole squared. So it would be a squared plus 2ab plus b squared. So it will be 16 plus 2ab, that would be 32c, plus 16c squared is equals to 6 into 20 plus c squared. Now I'll expand this part. It would be 16 plus 32c plus 16c squared, and this will be 120 plus 6c squared. Now I'll take these terms to this side, and it will be 16 plus 32c plus 16c squared minus 120 minus 6c squared is equals to 0. Now 16c squared minus 6c squared will become 10c squared plus 32c as it is, and 16 minus 120 is minus 104 is equals to 0. Now we can simplify it further also. Now to solve this quadratic equation, we can use midterm breaking or we can use quadratic formula. Over here I'm just simply going to use the quadratic formula. So that's basically equals to that c in this case is equals to minus b plus minus square root of b squared minus 4ac divided by 2a. Now do not confuse this c with this c, they are different. So minus 32 plus minus 32 squared minus 4 into 10 into minus 104 divided by 2 into 10, and I'll write the answers now. C is equals to 2 and c is equals to minus 5.2. Now we have two values of c over here, which one to choose? In the beginning they said that c is a positive constant, so that means that since c is a positive constant, c is equals to 2. This is our final answer of question number 10, part A. Moving on to part B. Show that the length of the perpendicular from this point to L is under root 11. Okay, so let's suppose this is our line L, alright, and somewhere over here we have this point 6, minus 3 and 6. Now they are saying that this line should be perpendicular to line N. Now let's name this point as X and let's name this point as P. Let's write the equation of line L. L had this equation that L is R is equals to 3 minus 2 1 plus lambda into 1 1 2. Now we know that if lines are perpendicular to each other, what does this mean? This means that the scalar product is 0. Whenever lines are perpendicular to each other, so the scalar product is equals to 0. Again, we'll use scalar product over here. And what will be the vectors? The vector from line L will be this, and the other vector will be px vector. So now let's see what can we do about px vector. Px vector is equals to ox minus op, right? Now what are ox and op? The vector ox, since x is lying on the line L, right? Since x is lying on the line L, ox will be equal to this whole vector. We studied this in vector properties that if there's a point that's lying on a certain line, so its position vector will be equal to the vector of this whole line. So that basically would mean that ox is equals to, now I'll combine them together, and it would be 3 plus lambda minus 2 plus lambda and 1 plus 2 lambda. This is the vector for ox. And what about op? Since this point is called P, so the position vector of P would be 6. The position vector of OP would be 6 minus 3 and 6. Okay, now let's find the vector Px. Px is equals to Ox minus OP. So Ox is 3 plus lambda minus 2 plus lambda and 1 plus 2 lambda. And OP is 6 minus 3, 6. Now we'll just separate the numbers with each other. So 3 minus 6 would be minus 3 plus lambda. And then minus 2 plus 3 would be 1 plus lambda. And then 1 minus 6 would be minus 5 plus 2 lambda. This is our vector Px. Now in scalar product, this is one of the this is one vector and the other vector is this, because in scalar product we always use the direction vector, so the other vector is this. So minus 3 plus lambda, 1 plus lambda, minus 5 plus 2 lambda dot 1 1 2 is equals to 0, because they're perpendicular to each other. Now we'll just multiply. Minus 3 plus lambda multiplied by 1 is minus 3 plus lambda. 1 plus lambda multiplied by 1 is 1 plus lambda. And now 2 multiplied by minus 5 plus 2 lambda is equals to 0. So minus 3 plus 1 minus 2 plus 2 lambda minus 10 plus 4 lambda is equals to 0. Minus 2 minus 10 minus 12 plus 6 lambda is equals to 0. 6 lambda is equals to 12 and lambda is equals to 12 upon 6, hence lambda is equals to 2. And we still are not done with the final answer. Now we got the value of lambda and we are going to put it in this equation so that we find the vector Px and then we'll find the magnitude. So Px vector will be equals to, now instead of lambda I'm going to put 2. Minus 3 plus 2, 1 plus 2, minus 5 plus 2 into 2, right? It becomes minus 1, 3 and minus 1. Now to find the magnitude of this Px vector, we will do under root of minus 1 square plus 3 square plus minus 1 square. And then the final answer would be 1 plus 9 plus 1, which is under root of 11. Hence we have shown that the magnitude of Px is under root 11. And this was what was written. We are done with question number. Moving on to question number 11. The variables x and y satisfy this differential equation. It's given that x equal 1 when y equal 1, and we have to solve the differential equation to obtain an expression for y in terms of x. So that means that we have to make y the subject. Now of course the first step, firstly I'm just gonna copy this. So x square dy by dx plus y square plus y is equals to 0, and I will separate the variables. So x square dy by dx is equals to minus y square minus y, and now I can say that x square multiplied by dy upon minus y square minus y is equals to dx. I just exchange the places of them. I just exchange their places. Now 1 upon minus y square minus y with respect to y is equals to 1 upon x square with respect to x. If I just take this minus sign outside, so it's y square plus y with respect to y and 1 upon x square with respect to x. I'm going to integrate them, right? So I can just take this minus on its side. So integrating 1 upon y square plus y with respect to y is equals to integrating 1 upon x square with respect to x. So now if you try to remember any kind of rule that we learned in integration to solve the algebraic part, we cannot there's no rule for it, so but we can see that this can be solved by partial fractions. So 1 upon y square plus y, which can be written as 1 upon y into y plus 1. So 1 upon y into y plus 1 is equals to a upon y plus b upon y plus 1. And now we're going to multiply this y into y upon y plus 1 on both sides. So it will be 1 is equals to a into y plus 1 plus b into y, and I'll take y is equals to minus 1 so that I can cancel this a. 1 is equals to, so it's going to be 0 minus b, so minus 1 is equals to b, and then I can take, suppose y is equals to 1, 1 is equals to a into 1 plus 1, and b is minus 1 and y is 1, so 1 is equals to 2a minus 1. Now 1 plus 1 is equals to 2a, 2 is equals to 2a, and 1 is equals to a. So now basically it is that a is 1 and b is minus 1. So this is basically 1 upon y minus 1 upon y plus 1 is equals to 1 upon y into y plus 1. So now we have the integration of, remember we also had this minus sign over here, so this whole integration will be multiplied by minus. So integration of 1 upon y with respect to x minus integration of 1 upon y plus 1 with respect to y is equals to 1 upon x squared integration with respect to x. So 1 upon y, when we integrate it, we get ln y, and 1 upon y plus 1. So if you see this, it's basically that f dash of x upon f of x form, like when the differential of this equation is going to be 1, right? So it's minus ln y plus 1. And when we integrate this 1 upon x square, so 1 upon x square basically means x raised to power minus 2 with respect to x. This is minus ln y plus ln y plus 1 is equals to, so when we integrate x minus x raised to power minus 2, we get minus 2 plus 1 is minus 1 divided by minus 1 plus c. We have minus ln y plus ln y plus 1 is equals to minus 1 upon x plus c. Remember, they give us these values, x is equals to 1 and y is equals to 1. We substitute these values and find the value of c. So minus ln 1 plus ln 1 plus 1 is equals to minus 1 upon 1 plus c. So ln 1 is 0, that becomes 0. This is ln 2 is equals to minus 1 plus c. So ln 2 plus 1 is the value of c. So the expression is minus ln y plus ln y plus 1 is equals to minus 1 upon x plus ln 2 plus 1. And now what we can do is that we can take all of these ln together on one side. So this becomes minus ln y plus ln y plus 1 minus ln 2 is equals to minus 1 upon x plus 1. And then this will be ln y plus 1 divided by 2y. So this will be ln y plus 1 divided by 2 from here and y from here equals to minus 1 upon x plus 1. We have to make y the subject, right? So ln basically means log to the base e. So y plus 1 divided by 2y is equals to e raised to power 1 minus 1 upon x, right? I just took this e to the, so basically ln is log to the base e, and over here we have our argument. So we have our argument, right? So this can basically be written as that argument is equals to e raised to the power, and in the power we write the term on the other side. So basically this is what I did over here. y plus 1 upon 2y is equals to e raised to power 1 minus 1 upon x. I'll take this y to the other side, so this becomes y plus 1 is equals to 2y e raised to power 1 minus 1 upon x. And now again I'll take this y also to the other side, will become 2y e raised to power 1 minus 1 upon x minus y. Now from here I'll take y common, so it's y common, so 2e 1 minus 1 upon x minus 1. So y will become 1 upon 2e 1 minus 1 upon x minus 1 is equals to y. 1 upon so y is basically 1 upon 2e raised to power 1 minus 1 upon x minus 1. The twos together. So this is an answer that y is equals to 1 upon 2e raised to power 1 minus 1 upon x minus 1. This is our final answer of question number 11, part A. In the marking scheme, they gave the answer as e raised to power 1 upon x minus 1 divided by 2 minus e raised to power 1 upon x minus 1. But these two are equivalent forms of each other, so this is also acceptable. This is the final answer. So part B says, state what happens to the value of y when x tends to infinity, and we have to give our answer in an exact form. So what happens to the value of y when x tends to infinity? Let's cover the expression y is equals to 1 upon 2e raised to power 1 minus 1 upon x minus 1. So if we see, right, when x tends to infinity, let's say that, let's write infinity over here. So 1 upon 2e 1 minus 1 upon infinity minus 1. So when x tends to infinity, this whole thing becomes 0. 1 minus 0 is 1. E raised to power 1 is just e. So this is 1 upon 2e raised to power 1 minus 0 minus 1. So 1 minus 0 is just 1, and e raised to power 1 is e, right? So y is equals to 1 upon 2e minus 1. So y approaches this answer, and they also said that given answer is an exact form. So y approaches this answer when x tends to infinity. Sometimes when you look at the expression as a whole, you can directly find out when x tends to infinity what's going to happen, but sometimes the expression is quite complex, so we break it apart, right? And it always, whenever they give this type of question when x tends to infinity, it always has to be in some sort of denominator, right? So this is the final answer of question number 11, part B, and we are done with the whole paper. Hopefully it helped you out, and thank you. See you in the next video.